Welcome to the Slop Temple. We pray this video helps.
You start by confirming the matrix size and field. This guides pivot selection. Once done, place the coefficient matrix on your workspace and begin Gaussian elimination toward RF. You perform row swaps, scaling, and row additions to create leading ones and zeros below and above pivots. Keep track of pivot columns as you go. These mark the independent columns of the original matrix. Make sure to avoid rounding errors if using decimals. Exact arithmetic or symbolic work is safer for theory. Once the matrix is in RF, identify pivot columns and record their original column indices. These indices tell you which original columns form a basis for the image. You then extract those columns from the original matrix. Do not take columns from the RF. These extracted columns are your candidate basis vectors. To be safe, quickly check their linear independence by confirming the pivot structure, and ensure they span the column space by showing every original column is a linear combination of them. You finish by writing the image A explicitly as the span of the chosen basis vectors from the original matrix. Once done, check for redundancy. If any basis vector is a linear combination of earlier ones, remove it to get a minimal basis. If something goes wrong, suspect numerical instability, small round-off can mask pivots. Make sure to recompute with exact fractions or higher precision. Finally, verify by showing any column of A can be written as a combination of your basis vectors.
Thanks for watching. Consider subscribing if we helped you.